All right, test Wednesday is 4.2 through 4.6. The review is separated by sections, so you can focus on what sections you need more help on.
How many questions would you have?
14 questions on the test, I think. Something like that. 13 or 15 or 14. One of those, around there. So the first part for 4.2, you're just adding or subtracting. So combine like terms. For B, we're dividing. For 4.3, we are dividing. The question on the test is just going to say divide. So you can divide using long division or synthetic division. You can pick. Pick whichever one you like better. So let's look at 4.4, number 1. So we are factoring here. How would I factor number 1? Take out the GCF, which is 5t to the third power. So 5t to the third power is going to go to the outside. What am I left with? T squared minus 64. All right, what's special about t squared and 64?
Different squares.
They're the difference of squares. So what would this factor into?
T to the second plus 64 and t plus 64 and t minus.
T plus 8 plus 8.
T plus 8 and t minus 8, because we want to break the t squared down and the 64 down. So our two factors of 64 are 8 and 8.
Okay, I'm sorry.
And then we still need that 5t to the third power on the outside. So this is our answer.
So t plus 8.
All right, let's take a look at 4.5, number 1. So here it says solve, but we're doing the same thing. So we want to factor first. Once we find all of our factors, we just set them all equal to 0 to solve. So what would I need to do first for number 1?
You could take out a q.
I can take out a q. So take out the GCF just like we would if we were factoring. So I have q squared minus q minus 30 is equal to 0. Now we want to see, do we have two factors of negative 30 that add to negative 1?
Yes.
Negative 6 and 5. So this would factor into q times q minus 6 times q plus 5 is equal to 0. So what would I do next?
You would equal the equations to 0.
Perfect. We set them all equal to 0. So each piece gets set equal to 0. Q equals 0. Q minus 6 is equal to 0. And Q plus 5 is equal to 0.
So q equals positive 6
And Q is equal to 0. So we get Q is equal to 6. Q is equal to negative 5. And Q is equal to 0. Yep. We have 3 answers there. So if you wanted to, for the answer, you could say Q is equal to 0, 6, negative 5. That would work too.
You don't want it like that.
That would be fine too. You don't have to. But. For number 3, what would we do first?
Oh, you gotta move the negative 3y squared.
I would have to add the 3y squared to the other side. Then we would take out the GCF and then we would solve. So it has to be equal to 0 first. So I'll let you guys do that one on your own. Let's go down to 7 through 10. So here we are finding the 0, so just like what we did above, and then sketching the graph. So we first have to solve. What would I do first to solve number 7? Take out an x squared. So x squared would come to the outside. I'm left with x squared plus x minus 12. Now, do we have two factors of negative 12 that add to 1?
Yeah.
What?
4 and negative 3.
4 and negative 3. So this would factor into x squared times x plus 4 times x minus 3. What would I do next? Set each piece equal to 0.
If it was plus 12, you just
then x plus 4 is equal to 0, and x minus 3 is equal to 0. So x is equal to what?
0, 3, and -4.
Perfect. X is equal to 0, x is equal to -4, and x is equal to positive 3. So these are 3 solutions here. So I can put them on my graph. I'm going to have a point at 0, at -4, and at 3. Now, in order to see what our graph is going to do, we need to know the multiplicity of each of these. So how many x is equal to 0s do I have?
1.
Are you sure?
What's 2?
2, because it's x squared is equal to 0. So because this is squared, that means I have 2 of them. So I have a multiplicity of 2 here. Is 2 even or odd? Even. So if I have even multiplicity, do I touch and turn or go through? Touch and turn. How many x is equal to 4s do I have? -4s. 1. So I have a multiplicity of 1. Is it even or odd?
Odd.
What am I talking about when I say even or odd? The number or the amount of that number that I have? So I have one of them. Is 1 even or odd?
It's odd.
1 is odd. So this would be odd. If I have odd multiplicity, do I touch and turn or go through? I go through. How many x is equal to 3s do I have? 1. So I have multiplicity of 1. Odd. Do I touch and turn or go through? Go through. When you have odd multiplicity, you go through. So now I also need to know the end behavior. How is my graph going to start and how is it going to end? So I look at the highest degree term. Is it positive or negative? Positive. So what is the right arrow going to do? Right arrow goes up. Now 4 is an even degree, so what's the left arrow going to do? It also goes up. They go in the same direction when it's even. So out of my point farthest to the left, I have an arrow that goes up. And out of my point farthest to the right, I have an arrow that goes up. So just copy these 2 arrows. All right. So now we're going to start from our left point and make our way to the right one. All right. So starting at -4, we start at the left. Does my graph touch and turn or go through at this point?
Through.
It goes through because I said I have odd multiplicity, so it go through that point. So through the x-axis at that point. Next, we're going to make our way over to 0. Do I touch and turn at 0 or go through? Touch and turn. So I'm going to touch the x-axis and turn. I don't go through the x-axis, just touch it. And then at 3, do I touch and turn or go through? Go through. So I'm going to make my way over to 3, and I would go through that point. So this would be my graph. So if you wanted to, your graph could look like this. As long as you have the shape, it's fine. Or if your graph looked like this, that would be okay too. Just the shape, the direction, what you're doing at each point. Any questions here? All right, next page. For the first part, 1 through 4, we just have to identify the number of solutions. So we're just talking about how many solutions we have. So for number 1, how many solutions would I have? 4, because I'm looking at my highest degree, so I'd have 4 solutions. And remember, solutions and zeros mean the same thing. For 5 through 8, we can factor these. But what happens if it doesn't factor? So like number 6, we can't factor that. What would we have to do? Last over first. So factor, or if it doesn't factor, we do factors of the last over factors of the first. And we have to test and see if this works using synthetic division. So you just have to find the zeros for these. Let's look at the next part. So 11 and 13 down at the bottom. Here we have to write a polynomial given the zeros. So we always have to remember, if it is a square root or an imaginary number, you need the conjugate pair. So these always need the pair. So in 11, am I missing any zeros? 11, this one. Do I have a square root? Do I have any i's? No, so I'm not missing anything. So these are just my 3 zeros. So when we write our zeros in factored form, it's always x minus the number. So if I have x minus negative 4, what does that turn into? X plus 4. So you always just change the sign. Then we have x minus 1 and x minus 2. What would we have to do next here? Foil it all out. So I'm going to leave that to you guys. Foil it out. Pick 2, foil it out, then multiply the third. For 11, our answer is going to start with x to what power? X to the third power, because we have 3 zeros. So you're going to multiply it out. You'll get x to the third power plus more. All right, so at the bottom, notice how the directions here. Yes. Notice the directions here are a little bit different. They say leave in factored form. So here we're just writing out all of our missing factors and leaving it as x minus whatever the number is. So for 11 down at the bottom, am I missing anything?
3 minus I.
Perfect, 3 minus I, the conjugate. If I have 3 plus I need its conjugate pair. So then when I write this in factored form, I have x minus 2, x minus 3 plus I, and x minus 3 minus I. This is where we stop when it says leave it in factored form. This is factored form. This is your answer. You don't have to multiply this out. You are done here. That's the answer. Yeah, positive square root 7. So any conjugate needs its pair. Any complex number. So if it's a square root or an I, it needs its pair.